Hello and welcome to Engineers Mindset Academy. All right, so we are going to be considering this other question to also determine the work done by a fluid or work done on a system from the surrounding. Okay, so this is actually a case of compression. Other videos we've done so far are a case of expansion. So let's consider the question. It says 1 kg fluid in a cylinder behind a piston is compressed reversibly according to the law PV equals 0.25, where P is in bar and V in meter cube per kilogram. If the final volume is 1 over 4 of the initial volume, calculate the work done on the fluid. All right, so let's pick out our parameters. First, we are given mass, 1 kg of fluid. So mass M is equal to 1 kg. Is compressed reversibly according to the law. Okay, so we're given law PV equals 0.25. And a condition was stated here. It says if the final volume is 1 over 4 of the initial volume. So you have final volume, okay, final volume, which is V2 is equal to 1 all over 4, sorry, of the initial volume. Initial volume happens to be V1. So you're simply saying that V2 is equal to 1 over 4 times V1. So conversely, this simply implies that V1 is equal to 4 V2. So keep this condition in mind. They are simply saying the initial volume is simply 4 times the final volume. All right, another thing to pay attention here is after the law, they said where P is in bar and V is in meter cube per kilogram. So in the introduction video, I talked about specific properties, and I said specific properties are those properties whose extensive values or whose total values are divided by mass. Those properties that are dependent on the quantity of matter in a system are called extensive properties. And of course, when you divide the extensive properties by mass, you have what is called the specific properties. So the specific property of volume is always symbolized with a small letter v, and it is simply what? Total value of volume divided by mass. So this means in order to, okay, so this means that the unit of specific volume is always going to be what? Meter cube per kilogram, because meter cube is a unit of volume, kilogram is a unit of mass. So that means if V is in meter cube per kilogram, it means from this law that this V here is a specific volume. Therefore, there will be a need to find what? The total volume. And to find total volume, which is capital V, it becomes specific volume multiplied by what? Mass. So what you cross multiply here, mass multiplies specific volume, then you have the total volume. So we always use small letters to represent specific volume and bigger letters to represent the total volume. All right. So it means from the law, we have to first of all convert this property to total volume. So we need to make volume first subject of the formula here. So from law, from PV equals 0.25, we simply make V subject of the formula by dividing through with what? P. So this simply implies that specific volume V is always going to be, in this case, 0.25 all over P. This is our specific volume. And to find total volume, we have to multiply this specific volume by what? Mass. Therefore, total volume V is equal to specific volume, which is 0.25 all over P multiplied by mass. But the mass given in the equation is 1 kg. So you have to do this. Should in case the mass is not 1 kg, let's say it is 2 kg, then which means you're going to be multiplying this equation by 2. But in this case, mass is 1. All right, so once you do this, this simply implies that total volume V is equal to 0.25 all over P. So it still remains the same thing, but now you've been able to convert it from specific volume to what? Total volume. So in an exam condition, you must do all of this. You must show this all out. You must show all this working as to how you cancel out the meter cube per kilogram to automatically become a meter cube. Because from here, if the unit of mass is, if the unit of specific volume is meter cube per kilogram, then I am now multiplying by mass, and unit of mass is kilograms. Notice now that kilogram cancels kilograms, and I'm left with what? Meter cube, which is the unit of volume, and this is what we've just done over here. So this becomes volume in meters cube. All right, this is now volume in meters cube. Again, it was stated that where P is in bar, so it means the pressure itself is in bar. So you still have to solve for pressure. After solving for total volume, we have to now solve for pressure. So we still cross multiply again. P multiply volume gives us PV to be equal to still 0.25. Now remember, you have to make pressure subject of the formula. So this simply implies that our pressure P is equal to 0.25 all over V. But it doesn't end there. The condition says pressure is in bar. So which means if this is the pressure, then in bar becomes times 10 to the power of 5 newtons per meter squared. Always convert your pressure from bar to Pascal. So this becomes our pressure. And if you find this, you're good to go. You now put in this value into the formula for work done. Remember, work done is equal to integral from V1 to V2 of pressure times change in volume, or PdV. So this is simply equal to integral. What is V1? V1 is simply 4V2. So you keep it here. V1 is 4V2 from the condition. If the final volume is 1/4 of the initial volume, and we converted this by saying V1 equals 4V2. So in place of V1, we have 4V2. Now, do not go and change the V2, as they said that the final volume is 1/4V1. Do not go here and put in place of V2 as 1/4V1. That will contradict the synergy. They must not all be in terms of V2. So if I have changed V1 to be 4V2, simply leave V2 as V2 so that two of them can easily cancel along the line. All right. Then in place of pressure, this is now my pressure, 0.25 by 10 to the power of 5 all over V multiplied by the V. I have this. But from integration principle, always take a constant of integration out of the integral sign. So 0.25 by 10 to the power of 5 is a constant. You pull it out. That will give you 0.25 by 10 to the power of 5 integral 4V2 to V2 of, I am now left with 1 all over V multiplied by dV. Okay. So we can now integrate. This is equal to 0.25 by 10 to the power of 5. If I integrate 1 all over V, I will simply have what? A natural logarithm of V. That will simply give me ln V. Okay, so put in the limits from 4V2 to V2, and I have this. All right, so work done is now equal to 0.25 by 10 to the power of 5. Okay, so now we can take our limits. Remember, putting the upper limit minus the lower limit in place of the logarithm or natural logarithm. Okay, so this becomes ln, in place of V, it becomes upper limit V2. So ln V2 minus ln, in place of V once more, lower limit, minus ln 4V2, and I have this. Okay, so work done is equal to 0.25 by 10 to the power of 5 into, now from the principle of logarithm, once the log of two numbers subtract themselves, you pick one of the logarithm and divide their numbers. So I have ln V2 minus ln 4V2. These are logarithm. Pick one of them and divide their numbers. This will simply give me ln V2 all over 4V2. So you pick the first one, ln V2 divided by 4V2. So from here, observe that V2 cancels V2. So work done is equal to 0.25 by 10 to the power of 5 into, I am now left with ln 1 all over 4. And ln 1 over 4 is actually 0.25. So this is actually work done equals 0.25 by 10 to the power of 5 into ln 0.25. Okay, 1 over 4 simply means 0.25. and hence work done equals 0.25 by 10 to the power of 5. Let's now obtain lane 0.25. Lane 0.25 is approximately minus 1.39. All right, so we simply multiply that value. This implies that work done is equal to 0.25 by 10 to the power of 5 multiplies minus 1.39. This simply gives us approximately minus 34750 in joules. Okay, so it means the work done is minus 34750 in joules. Now we have minus, and I said in the introduction video when we talked about sign conventions that when work is done on the system, then that work is negative, or when the system undergoes compression process, then the work done at that point is negative. And if you read through the question once more says 1 kg of fluid in a cylinder behind a piston is compressed reversibly. So since the fluid is compressed, it means the work done becomes negative. This simply means work has been done on the fluid. Therefore, that work done is what? Negative, and which is why we are having a negative value as the result here. All right, guys. So I think that will be the end for calculations involving work done in a thermodynamic system or work done by a thermodynamic system. In the next video, we can start talking about the first law of thermodynamics, polytropic processes, and all of that. I will see you in that video. Thanks and cheers.